Hi, welcome to the pre-calculus lecture series. And this video, we're going to cover the section 7.3, and we're going to cover several very, very important trick formulas. And those formulas we use quite frequently in the calculus, especially sometime in the calculus to the integration part. Okay, so we're going to cover the double angle, half angle, and the product to sum formulas here. Okay, let's go ahead, start, take a look our lecture notes here. So the first important set of the formula we're going to talk about, it will be the, so here, let me see here. So it will be the double angle formulas here, right? So for the double angle formulas, we have the three things here. So in here, I'm going to write it. This is the sine 2x here. All this you can, if you want to prove, if you want interesting to prove, it's all use the formula we did in the, for the first two sections, right? The sine x, like the sine alpha plus beta, you can use that to find those formulas here. So we said the sine 2x is 2 sine x cosine x. But in here, I think we just need to know how to apply the name, and we're not going to prove it. If you are interested, I say you can always try to prove it from the sine x plus y and try to solve it. Okay, so for the cosine 2x, in fact, we have three different formulas. So you can say this is cosine square x minus sine square x. Or you can say this one's here, you just replace by use the Pythagorean theory. So you can say this is 1 minus 2 sine square x. Or you can say this is the 2 cosine square x minus 1. So from here to here, you can just replace with the Pythagorean series, right? So like in here, you can replace the, the cosine square x is equal to the 1 minus sine square x. Right? So that's what we talk about is the Pythagorean series here. You replace this one and to here, that's what you get these formulas here, right? So this cosine. Okay, so now the last ones here is we talk about is tangent 2x. So the tangent 2x here, this will be the 2 tangent x, and this is 1 minus tangent square x here. Like I say, all the proof here, you can prove if you are interested. You can just start this way, like sine 2x. You can use the formula we have it before. It's become sine x plus x, right? Then this will be the sine, cosine, cosine, sine. So the same is the cosines here. So you can do this and try to find it. So this will be the sine x, cosine x plus cosine x, sine x. That's why you got the 2 sine x, cosine x. So the proof is quite simple. Okay, so this is what we call this the double angles here. So in fact, the double angles here, right? So you can like change the form a little bit, and then it will become quite handy when we try to lower the powers here. So like if you use the cosines here, so let's see here. So the first one here, I'm using the cosine is equal to the 2, like the 1 minus sine x here, right? So when we mean the lower the powers here, so you do a little bit of algebra. So we said the cosine, so you can say the sine square x is equal to, you just move over here, so you divide by 2, so it will be 1 minus cosine what 2x here. Did you see here? That's why let me color coding that. So you can, from the double angle, you can change that. We call this lowered powers here. Then it's the same way for the cosine x squared. If you want to lower the power here, so you can use these formulas here, right? So this formula, you can say this is a cosine square x. This is equal to 2 the 1 plus cosine x. All right, so this is what we said you know, by using the color coding there. Okay, so then the same ways here for the tangent x here, right? So because we know the tangent x here just sine over cosines, right? So the tangent square x, you can drop it to 1 minus cosine 2x, and this is 1 plus cosine 2x. So here, this formula is extremely useful, you know, in the integrations. Okay, so it's extremely useful in the integration. That means it's in the calculus 2 part. Because sometimes, you know, like when you try to integrate the sine square x, sometimes it's not that easy. So you can use this double angle formula and try to bring it down to the lower powers here, right? So you can bring down to the lower power. So you can just integrate the cosine 2x instead of square x here. So that's why I say it's pretty handy formulas, you know, like in the calculus. Okay, so now let's take a look at some example. How do we use those formulas here? Okay, so the first one is here. It says cosine equal to the negative 2/3 is in the quadrant number 2 here. I want to find the cosine 2x here, right? So then you use a double angle. You say the cosine 2x. All right, so well, you directly use the cosine x, right? So you can say the cosine 2x is 2 cosine square x minus 1. So you can just plug in these ones here. So this is negative 2/3, right? Square minus 1. So what is this one here? So this will be a over 9 minus 1. So this will be negative 1 over 9 here. All right. Then the sine 2x is here. Okay, so now the sine 2x, I can use the formula for the double angle. So it's 2 sine x cosine x. I already know the cosine x is negative 2/3, so I can go to find the sine x, right? So this is my x here. Cosine is adjacent over hypotenuse, right? So this one, so what is here? This is square root of the 5 here. Okay, so now I said 2, but now be careful here. So the angle theta is in the quadrant number 2 here. So in the quadrant number 2, what is my sine value? Sine is positive, right? So that will be the square root of the 5 over 3. Then the cosine still is negative 2 over 3, the negatives, right? So times it 9, so this will be 9 negative 4 square root of the 5 here. All right, so now let's take a look at example number 2 here. Example number 2, let's say, hey, change the cosine 3x in terms of the cosine x. So I say, okay, cosine 3x. So the 3x, I can use the sum formula we did in the previous section. So it's a 2x plus x, right? Then the cosines, right, is cosine, because it's plus is what is minus sine sines, right? So we have a cosine 2x, cosine x minus sine 2x, sine x, right? So by the sum formula, because it wants us to change only to cosines, right? So now I need to, so this is my trouble terms here, the cosine 2x here. So I need to change that. But I know the cosine 2x, so double angles, I can say that this one here will be the 2 cosine square x minus 1. Then this is cosine x, right? So now I change this term all to the, okay, so all to the cosine. So that's good. Okay, so now in here, I have sine 2x and sine x. Okay, so now I using the double angle, right? So my double angles tell me sine 2x is equal to sine x cosine x, correct? So I have still the sine x here, okay? And now in here, you say this one's here, you can just FOIL it out. So this is a 2 cosine 3x minus cosine x. Okay, so in here, this is a 2 sine. So in here, you have a cosine x, and then you have a sine square x here. All right, so I still have troubles here, right? Because the sine square x, I need to replace it with a cosine x because the problem say, hey, change it to cosine x. So all the others is in a good shape, right? So the cosine 3x, x cubed minus cosine x minus cosine 2 cosine x, right? So what is sine square? The Pythagorean series, right? So I can say this is 1 minus cosine square x. Okay, so be careful about our algebra. So this is 3x minus cosine x. FOIL it, minus 2 cosine x. Minus is plus 2 cosine what? Cube x. So combine the similar term, right? So this term and this term is similar terms, and this term and this term is a similar term. Okay, so now I combined it, I will have what? 4 cosine cube x minus 3 cosine x here, right? So in here, this is pretty good problems. I just want you to try to practice the double angle Pythagorean and then the back and forth here. All right. Okay, so this is a double angle. Now we talk about the half angles here, right? So the half angles here, okay, so let me try to write here. So the sine x over 2. So right now I have the half angle. This will be equal to plus minus. Okay, so this is 1 minus cosine x over 2. Okay, so it's just used that a while ago, we kind of is reverse of the double integrals, right? So double angles here. So double angle, so in here you can treat x equal to 2 times 2x over 2. Okay, then we have a sine, cosine. Okay, so then we have a cosine x over 2. So this one's here will be plus or minus. This one's here is 1 plus cosine x over 2, right? Then the tangents, right? So the tangent x over 2, it will just be equal to the 1 minus cosine x, 1 plus cosine x. Okay, so it's 1 minus cosine x, 1 plus cosine x. Or you can, do like so it's 1 minus, so tangent over 2 is a cosine over sine, right? So it's 1 minus cosine x. Okay, so here, I need to write it correctly. So here, this will be, so here, this one, if you simplify it, you can get this is the sine x here, or you can say this is the sine x, then this is the 1 plus cosine x here. Okay, so then you were wondering, you say, hey, what is this plus minus here? Okay, so this plus minus is here, right? So the choice, so which one will be the correct one? So the choice of the plus or minus is depend on the what? So it depends on the quadrant which x over 2 lies, right? So you need to know where is the x over 2. So, the which quadrant, because I know sine going to be positive in the quadrant number 1 and 2, right? So if the x over 2 laying on the quadrant 1 and 2, then it's positive. And we know the cosine going to be positive at quadrant 1 and quadrant 4, right? So that's why when you do the cosine here, if the x over 2 is quadrant 1, the 4, then you choose positives, right? So let's write a sheet notes here. So like if this axis here is in the quadrant 1 and 4, then you take a what? You take positive signs, right? So the same here for this one's here. If this one's in the quadrant 1 and the quadrant what? Quadrant 2, then you take the positive signs, right? Because the sign is a positive. All right, now let's take a look. Find the exact value of 22.5. Okay, 22.5. So that means this is the half angle for what? This is the half angle for the 45 over 2, right? Okay, so now I can say this is the sine, right? So the 22.5 degrees, I can write this is the sine 45 over 2, right? So my x here is 45 here. So 45 is a special angle. Then it is in the first quadrant. So I will use this will be equal to the 1 minus what? 1 minus cosine 45 over 2, right? Because it's a positive here. So what is the 1 minus cosine is the square root of the 2 over 2 over 2, correct? Okay, so now if you simplify it a little bit, so if you simplify here, okay, so then this one's here will be equal to, you got a big, so here, so this is a 2, so find the common denominator. So this is 2 minus square root of the 2, then here you have a 4. This is 2 minus the square root of the 2. So 4 come out, so it's 1/2, 2 minus the square root of the 2. All right, okay, so now let's take a look. The next problem here, tangent half angle. If the sine u is equal to 2/5 and u is equal in the quadrant number 2 here, now I'm going to find the tangents here, right? Okay, because they already tell you u, so I'm going to use the tangent u over 2. I'm going to use the first ones here. This will be 1 minus the cosine u, the sine u, right? Because I already know u is 2/5. Okay, so now let's take a look here. This is my u. So the sine equal to 2/5. So this is 2/5. And so what is the, by Pythagorean theory, this is 21 here, right? Okay, so now this one's here, this is the 2/5 and the 1 minus, so cosine u is equal to the adjacent over hypotenuse, is 21 over 5. All right, but in here, let's say, the u is in the quadrant number 2. So what is the cosine? Is it positive or negative? It's negative. So it's negatives here, right? So don't forget that's negative. So now it's a minus square root of 21 over 5, right? So now this one will be 2/5. And this is 1 plus 5 over the square root of the 21. So if you simplify a little bit, so you can cancel the 5, then this is 5 plus square root of the 21 here, right? So be careful about the positive and negative signs, okay? All right, so now let's take a look at another example. This is sine 2 cosine x here, arc cosine. Okay, so this is what we learned many times. You know, if you see arc cosine, so we need to do what? We need to draw triangles first, right? So here. Okay, so now this is my theta, right? So arc cosine x over 1, right? So this is x, this is 1. By the Pythagorean, what is here? This is 1 minus x squared, right? Okay, so this is the theta, right? So the here, this is the theta. So look at my color codings, right? So now this one's here, I can rewrite, this is a sine 2 cosine x. I can write this is the sine 2 theta, correct? Okay, after I write sine 2 theta, I see this is what? This is a double angle. I know the formula is 2 sine theta cosine theta. So the 2 sine theta, sine the opposite over hypotenuse is 1 minus x squared. Cosine x. It's good. All right. So that's why the answers here we have, this is a 2x, 1 minus x squared. Okay. So so now the next one's here. Let's take a look here. The example number 6 here. Okay, so the sine 2 theta where the cosine equal to negative 2/5 here. Okay. So now, okay, so now in here, we can say here the sine 2 thetas, right? So the double angle. So the sine 2 theta is equal to the 2 sine theta cosine thetas, right? Okay, so the cosine theta, we already know, all right? So it's negative 2/5. Okay, so let's try here. So this is my theta. So cosine is 2/5. So this is 2, this is the 5. So what is here? This is 21. All right. Okay, so it's 5 over square root of the 21 here. Okay, because the theta is in the quarter number 2, so what is the sine theta? Sine theta is equal to the negative 21 over 5. Because it's a quarter number 2, the sign is a positive or negative. It's a positive, right? So now I can substitute these values here. This will be 2. Then the sine theta, so will be the square root of the 21 over 5 times the cosine here is 2 over 5, right? Okay, so now the cosine here, don't forget the cosine here has a negative. I almost did not see that. All right, so what is the here? So this will be 25 negative 4, the square root of 21 here. Okay. So those just the back and forth, the double angle, half angles, right? Okay, so now the next things here, we are going to talk about the product to sum formulas here. This is also, you can prove it by using, the sine u plus v formulas to do it. So in order to use it, so we don't need to know how to prove it. If you want to know how to prove it, in fact, it's not too difficult to do that. Okay, so here the product to sum formulas here. So if I have sine x cosine y, okay, so this one's here, this will be equal to the 1/2 the sine x plus y, okay, plus the sine x minus y, okay. So the same if I have a cosine x sine y, cosine x sine y, then I have 1/2 sine x plus y, then minus sine x minus y here. So if I have a cosine, okay? So if I have a cosine, this will be 1/2 cosine ux plus y, and then plus cosine x minus y, okay? Then if I have a sine, okay, sine, so this one's here, I will have 1/2, this is cosine x minus y, then minus cosine x plus y here. Okay, so here be careful about, so the things here, you be careful about this is positive and negative, and then in here you switch it to the positive and negative, and the special these two, so be very careful, right? You switch the orders here. And like I said, those formulas here, you can have a formula sheets and summarize all this, or, if you can derive it, that'd be good. All right. Okay. So now, okay, so this is a product to sum. Okay, so now let's take a look. It said express the sine 3x as a sum. So this is the sine 3x, the 5x, right? So sines, right? Okay, so let's say here, this is a sines, right? So make sure this is your xy's in your formula. Okay, sine. Okay, so this is a sine 3x, sine 5x. So the sine, I use this formula, right? So this is 1/2, okay? Cosine x minus y. So what is here? 3x minus 5x, correct? Okay, then minus cosine. You add these two angles, so it's 3x plus 5x. All right. Okay, so now this one become pretty easy. So this is 1/2. This is cosine negative 2x minus cosine ax, right? Okay, so now we know the cosine is the even functions, right? So that's why the cosine 2x, negative 2x will be equal to the positive 2x. So minus cosine ax is here, right? So from here to here, right? So this one to this one here, the reason why is what? Because the cosine function is an even functions, right? So we know an even function, then you have the negative, and then the negative is just kind of like the disappears here. All right, so now let's take a look at our last set. Last one is the sum to the product, all right? So the sum to the product, okay? So let me try to write the formulas here. So it's the same things here. If I have a sine x plus sine y, okay, so this would be equal to the 2, okay, so this is a 2 sine, all right, x plus y. Okay, so this is x plus y. So you use the half angles here, then the cosine x minus y to the half. Okay, now if you have a sine x minus sine y, this one will be 2, the cosine, this is x plus y over 2, then this is the sine x minus y over 2. How about if you have a cosine x plus cosine y, then this one will be equal to the 2 cosine x plus y over 2, and cosine x minus y over 2. Now here I have a cosine x minus a cosine y. So this one's here, be careful, you have a negative 2 sine x plus y over 2 and sine x minus y over 2. Okay, so this is the one, be careful about this negative signs here. Okay, so now let's take a look at the example. So example is like the write sine 7x plus 3x. So it's a sine plus sines, right? Okay, so let's try to do that. So the sine plus sine, all right? So the sine plus sine is equal to the 2 sines, right? So this is 1, okay? So I have a sine 7x plus sine 3x. This will be 2 the sine, okay, so you add them together is 7x plus 3x divided by 2. Then you have a cosine. So here, this is 7x minus 3x over 2. Okay, so this is the sine 10x, so it's 5x. And 4x is a cosine of 2x here. All right. Okay, so now let's take a look at the last proof ones here. So the last proof one, so it's a 3x minus x equal to tangent x. So like we said, we typical from the, we work on the more complicated side. So I'm going to start with my left-hand side, right? Okay, so the left-hand side is the sine 3x minus sine x. So it's a sine minus sine. So I'm using the second formula, right? So this will be 2 cosine, all right? 3x plus x, 3x plus x over 2, and times sine 3x minus x over 2. Correct? That's the second formula. Then cosine plus cosine, cosine plus cosine, I'm using the third formula. So this will be the 2 cosine. You add them up, 3x plus y over 2. All right. Then you said cosine 3x minus x. So, right, so your y is x over 2. All right, so here. All right, so now let's simplify it a little bit. This is the 2. This is the cosine. 3x plus x is 4x. Divided by 2 is what? It's 2x. Okay, sine 3x minus x is 2x. 2x divided by 2 is sine x. All right, so this is the top. Then the bottom here is 2. This is the cosine. 3x plus x divided by 2 is what? It's 4x divided by 2 is 2x. Cosine 3x minus x is 2x. So it's cosine x. Wow, that's good. A lot of things we can cancel. 2 and 2 cancel. Ooh, this one is cancel. Good. It looks very complicated. It turns out to be pretty cool. So this is sine x over cosine x is equal to what? Is tangent x equal to my right-hand side. So I'm done with the proofs here. All right, that's it. And so as you can see, this is like, right, so this set, we have 4 different sets of the formula, right? The double angle, half angle, product to sum, and the sum to product here. All right. Like I said, probably like the double angle, half angle is very useful in the calculus, especially, like in the calculus 2, the integration part, we use a lot of that. Okay. All right, that's it. That is the for this, for these sections here. And that's it. And you have a good day. And looking forward to talk to you in our next sections here. Okay, bye.